So for the third order, the scientists assume that this third order polarization depends on the triple products of E field. So this is just assumption. It may be wrong, right? So nonlinearity, by using this kind of perturbation expansion, is just one way. It's approximation. It's better than no method to tackle it. So whether this is right or wrong, we can do experiment to apply strong field and to make sure that to test whether it is correct or not, whether the theory is correct or not. A theory is a theory. A theory might be wrong. Okay, so we do like this, and so this kind of methods exists for many years already, since 1940 or 60s, and most of the time it proved that it is correct, provided the strong field is not too strong. You get what I mean? Yeah, and you know that I don't know whether I've said to you or not. If this E field is very, very strong, you can destroy the material. You have no choice. You have no chance to see whether it is melt or become softer or whatever. If this E field is very strong, I mean the amplitude of the field is very strong, you just directly burn the material. All right. I don't know whether you have do experiments or not. If you are a child, if you have played with the magnifier, all right, a glass of magnifier, you put a paper under the hot sun, okay, midday, under the hot sun, you use your magnifier, and then you focus your sunshine on the spot. Just a while, you just burn the paper. You get what I mean or not? Yes, I'm happy that you've done this before. Then you know what I said. Because when I was a child, I quite naughty also. I like to play with all these things. Play with whatever I can find at home. So this kind of burning paper under the hot sun is my favorite games. But of course, kena lah. You can see your parents don't like this, right? So what to do, you see? So, but I think this is helpful for us to understand how it is. Okay, so this is, I hope that you understand this is approximation, all right? So I hope that you understand, you can accept what I said. Nonlinearity is a kind of things like this. Okay, so if you're happy with our second order, okay, I make it yellow again. So we are going to use this after this. All right, so to split the chi, so P equals to epsilon naught chi E. When come to the nonlinear, so we split the chi into chi1 for the first order, and we have the second order chi, we make it split like this. This is just mathematical techniques. All right. Because of in nature, for linear, we have simple terms like this. And in the perturbation theories, when you have when you have to expand the terms into series, into series like this, likewise for your chi, you have to follow the expansion. But of course, you have to give it different name. For the first order, you make it chi1. For the second order, you say that it is chi2, and then for the third order, you say that it is chi3. And the chi here have to follow the E. If your E is real, your chi have to be real. If your E is complex, two terms, complex and conjugate, you have to follow also. If the products has four terms, okay, this you have four terms. If the E are complex, then this one you have to follow split to four terms. This one will give us 8 terms. This chi you have to split into 8 terms also. All right. So this is the concept of series expansion. All right. I have taught the mathematics, ZCD to 10 for many, many years. So this one, if you still recall your series, Frobenius power series, is something similar things. Okay. Actually, nothing new, but just the terms looks complicated. All right. So we have finished our second order expansion. Let me see the time. We still have 20 minutes. A bit rush. So you don't need to copy. I think you just take photo. All right. And then after this, we have to expand our E, products of 3Es. Okay, products of 3Es are like this. All right, so E. So this is our E, E and E. Yeah? Okay, and then you just expand and you just multiply. You have 8 terms. Okay, and then 8 terms here. Every term you simplify. For example, this term you can simplify. Exponent minus I omega t. There are 3 terms here, so you become exponent minus I 3 omega t. Yeah? So the field, you never throw the field away. Yeah? So you have E naught x, E naught x, E naught x. The second term, okay, now is our bistability is depends on this, the triple E, but the term dependence is minus I omega t. So this is positive I omega t, exponent negative I omega t, exponent negative I omega t. So the result is exponent negative I omega t. The field is conjugate complex. So conjugate complex. So you have two similar terms like this. Okay, and these two are conjugate of these two. Okay. No, you have 3 terms. You have 3 terms. So you have 3 terms like this with the exponent negative I omega t. So this term and these 2 terms are the conjugate of this. And the last term is the conjugate of this. Okay, so all together we have 8 terms. And then we are ready to find our P3. So P3 we just copy, paste, and then after this we split the chi. So our P3 still got the one subscript I, but now the chi you have 4 index. The first index I is for the P on the right hand side, and you have the XXX here is for the 3 field here. So all are XXX because we apply only the X field. So is it okay? Now up to this, is it okay now? You can fully accept what I said.
Yes, doctor.
Okay, so now we managed to expand the P1, P2, P3. So we have one more thing to do, right? So we have the P1, P1, P1. Okay, we have the P to the power of 3. Okay, let me help you to recall this. We have the P to the power of 3. Okay, we have the P to the power of 3 here. When we expand, we just want to retain the up to maximum 3 amplitude. So it's this term. So we work it out here. The workout is here. Okay, so this one I changed to yellow. Okay, this one we have to use later. So this one PI is based on the P1 that we have just worked. Okay, we use this and substitute into here. Okay, P1, P1, and P1. So when you expand it, then you can see, and of course I expand it and then I collect all the time dependence. Okay, so I have 8 terms like it. 1, 2, 3, 4, 5, 6, 7, 8. I have 8 terms. So the 8 terms, it follows almost like the 8 terms here, but except it is no more chi3. But the combination of the chi. So for example, the first term you have exponent negative I omega t. This complex. You have chi ix like this, minus omega and positive omega in the argument. So these 3 terms are the same. All right. And then this term is the conjugate. So this is this positive omega and negative omega. And this one are the 2 conjugate field. No, 2 complex field. So the chi are follow. So this complex chi is this minus omega